So here we are now talking about the third in our series of sort of simple structures, and that's the U structure, which is really pretty basic. It's comprised of one base plate and two verticals. And the handy thing about the U structure is that the two verticals can create two sort of parallel mounting surfaces. So if you need to, for example, align a shaft, let's say, the U structure is great for supporting that shaft. So you can see I've kind of drawn the beginnings of a shaft here on this simple U structure that I'm drawing, and I'm kind of drawing the hole in the place where the shaft will protrude from the right side, and I'll just kind of maybe stick a knob on the end here, kind of give it some markings and a set screw, and finish off my U structure, and of course my cutout lines. U structure will be really useful in a lot of different contexts, primarily for suspending things, between two supports. So all shafts typically are supported in at least two places, just so that the load is kind of evenly borne by two different supports. Cantilevered shafts can be a bad idea. Okay, so if I want to kind of level up a little bit in terms of stiffness, I might build a U structure with some flat pieces and reinforce it with some machine screws, which I'm drawing here. So we could imagine that we have tapped holes in the vertical members and clearance holes drilled in the base plate. And we'll just thread those machine screws into the vertical members and reinforce the whole structure. Now, if you've watched any of the other structure videos, you probably know what's coming next, which is the next way to stiffen this thing even more is to create some type of mechanical interlock between the parts even before we add any fastening technique. And so what I'm drawing here is a U structure made from a base plate and two verticals that uses dado joints. So we've used dado joints in some of the other structures already, so this particular approach should be no surprise to you. And then I just decided I want to reinforce everything again with some machine screws, and we'll assume that there are tapped holes in the vertical members of the U structure. So leveling up one more level in terms of maybe complexity, strength, stiffness, etc., we could attempt to make the U structure all one piece. And the first and easiest way to make it all one piece is to assemble it from multiple different pieces, right? And if we're using metal, using welding, we can effectively make the whole thing, the entire structure, all one piece. So I'm drawing in the kind of rounded edges of the welds, adding some lines to try to suggest some curvature to these welds, which are a little bit exaggerated. And I am putting in the symbol which indicates that the weld extends the seam, the full length of the seam on both sides. And finally, if we were going to manufacture a whole lot of U structures for use in building some complicated machines or something like that, we might actually want to make the U structures be extruded from one continuous piece of aluminum. So extrusion, again, is the process of pushing a ductile material through a die with a particular cross-section cut in it. So we'd have a U-shaped cross-section, and we might push some warm metal through that die to create this extruded U structure, which is going to be the stiffest of all of these structures, and in part because it's extruded from a single piece of metal, but also because, as I've drawn the geometry, you can see that the verticals of the U actually get wider toward the base. And so that widening toward the base will actually create a much stiffer structure than if they had a uniform cross-section all the way from the top to the bottom. Finally, I'm just adding in some arrows indicating kind of the direction of increasing stiffness for this structure. Okay, that's about it. That does it for the U structure. Very handy structure for prototyping.